The price demand relation for a particular clock radio is given by this relation, that is x equals 3000 minus 10p, where x represents the number of clock radios and p is the price of the clock radios, and this price p in dollars. In part A, we write p in terms of x and we also determine the domain of p. So using this equation, I'm going to rewrite in terms of p. So I'm copying this x equals 3000 minus 10p. Now I add 10p to both sides, so therefore this becomes 10p plus x. This equals 3000, and I subtract x from both sides. So I get 10p equals 3000 minus x. Now I divide both sides by 10 so that I get p on the left side. So this equals p equals 3000 minus of x over 10. And this could be rewritten as 3000 by 10 minus x by 10. 3000 divided by 10 is 300. So therefore the relation is written in terms of x as 300 minus x over 10. So we have written the p in terms of x, which is equals 3000 minus x by 10. Now let's determine the domain of this function. We know that x represents the number of clock radios. So this has to be a positive number, which means x has to be greater than 0. And p basically represents the price in dollars, so this should also be greater than or maybe equal to 0. So we say that x greater than 0, p greater than 0. Using this p greater than 0, we can determine the upper end of the domain of the function. That is, I utilize the p, which is 300 minus of x over 10, and this has to be greater than or equal to 0. And so we solve this inequality. I'm going to add x over 10 to both sides. So I will get 300 greater than or equal to x over 10. Now I multiply both sides by 10. So I'm going to get 3000 greater than or equal to x. Otherwise, we can say that x less than or equal to 3000. So therefore, we see that this is also equal to 0. We see that x greater than or equal to 0 and less than or equal to 3000. So this is the domain of the function p. We can write this interval notation as 0, comma 3000. And so this is the domain of p. Let's answer part B. So here we have to determine the function r of x, which basically represents the revenue function, and we have to determine the domain. So I'm going to write down the formula for r of x, which is the revenue function, and this equals x times of p of x. So basically this equation is p of x, that is this is the price function. So we will write down this as x times of p of x is 300 minus x over 10. I distribute this x into the terms inside the brackets. So x times of 300 is 300x minus x times of x over 10 is x times of x is x squared over 10. So this is the r of x, which represents the revenue function. We now determine the domain of this revenue function. So as we know that x basically represents the number of units, and this has to be a non-negative number. So we say that x has to be greater than or equal to 0. And also this revenue should also be non-negative. That is r of x should be greater than or equal to 0. And this means we say that 300x minus of x squared over 10, this has to be greater than or equal to 0. So let's solve this inequality. I'm going to add x squared over 10 to both sides, less than or I'm sorry, I'm just going to multiply both sides by 10. So when I do that, I get, if you multiply this by 10, this will become 3000x, and x squared by 10 multiplied by 10, we get this 10 cancel. So we will have x squared, and greater than or equal to 0 times of 10 is 0. So we have this inequality. Now let me factorize x, that is, this will become 3000 minus x greater than or equal to 0. We can determine the points where x is 0. That is, suppose if we set up this as an equation, we will get x times of 3000 minus x, and this equals 0. So we know that there are two values of x which makes this equation 0. That is x equal to 0 or x equal to 3000. So we can put this in number line. We have x equal to 0 and x equal to 3000, and we take some random values such that it satisfies this inequality. Suppose if we take x less than 0, this will be negative, this quantity will be negative, and this quantity will be positive. And let's check if this is greater than or equal to 0. Negative times positive is negative, but so negative number is not greater than or equal to 0. So we ignore the points which is less than 0. And if we take any number or any x value in between 0 to 3000, let's suppose that we take 1500. So we plug it into the inequality. So we will get 1500 times of 3000 minus 1500 is a positive number, and this is greater than or equal to 0. So this is positive times positive is a positive number, and this is greater than or equal to 0. So it satisfies in this interval. That is, this inequality is true when we take any values between 0 to 3000. So clearly we can see that x greater than or equal to 0 and less than or equal to 3000. Otherwise, we can write this in interval notation as 0, comma 3000, and this is the domain of R. Let's answer part C. So here we determine marginal revenue at 2200 clock radius. So first we write down the expression for marginal revenue. Marginal revenue is basically the derivative of the revenue function. So I write marginal revenue. This is the derivative of revenue function. So we have the revenue function R of x. So this is the derivative of R of x, which we can write down this as R prime of x. So let's determine R prime of x, which is the marginal revenue. R prime of x is derivative of the revenue function. I will copy the revenue function. R of x equals 300x minus x squared over 10. So we find the derivative of each of the terms. Derivative of 300x is 300 is a constant, and derivative of x is 1. I put this as 1. And then we find the derivative of x squared, which is 2x over 10. So this could be simplified. This goes 5 times. So this equals 300 minus x over 5. So this is the marginal revenue function. And since we want to calculate the marginal revenue at 2200 clock radius, we replace x by 2200. So therefore, this becomes r prime of 2200, and this equals 300 minus of 2200 over 5. So when we divide 2200 over 5, we get 440. So it is 300 minus 440, and this equals negative 140. So we have determined the marginal revenue at 2200 clock radius. In part D, we interpret R prime of 2300, which equals negative 160. So there are two ways that this can be interpreted. So first, let's interpret the first way. It is when selling 2300 units, the price or the revenue is increasing. Here it is decreasing because we have negative. It is decreasing at a rate of $160 per additional unit sold. So this is one way of interpretation. It is when selling 2300 units, the revenue is decreasing at a rate of $160 per unit sold. Now let's understand the other way of interpreting this. So we can also say that if sale or 2300 units, one unit increase in sales will result in approximately a $160 decrease in revenue. So this is the other way of interpretation. That is, if sales are 2,300 units, a one unit increase in sales will result in approximately $160 decrease in revenue. So this is the interpretation of R prime of 2300.